So, dear students, let's start with this very basic information कि हमारा जो स्टेक्योमेट्री है व्हाट एक्चुअली मीन्स और इसमें हम जितने भी केमिकल रिएक्शंस हैं जो कि डिफरेंट स्टेजेस में टेक प्लेस करते हैं लाइक हमारी कोएगुलेशन का प्रोसेस टेक प्लेस कर रहा है, प्रेसिपिटेशन का प्रोसेस है, हमारी जो फ्लाकुलेंट्स की जो स्टडी है, एड्सॉर्बेंट्स की जो स्टडी है, उनके ऊपर अगर हम फोकस करें तो उसमें जितने भी केमिकल्स, जितने भी कंपाउंड्स अपना रोल प्ले करते हैं, एक्टिव पार्टिसिपेट करते हैं, वी नीड टू अंडरस्टैंड कि वो किस क्वांटिटी के अंदर रिएक्ट करते हैं और कितनी क्वांटिटी के अंदर रिक्वायर्ड रिएक्ट करेंगे तो हमें अपना रिक्वायर्ड जो कंटेंट है वो अवेलेबल होगा। सो इस तरह से हम इसको बहुत ज़्यादा जो है वो स्पेसिफिकली मेजर करना चाहेंगे ताकि हम अपने एक्यूरेट रिजल्ट्स को अचीव कर पाएँ। फर्दर मोर इसमें एक और भी इम्पॉर्टेंट चीज़ है कि हमारा जितना भी रिएक्शंस का निज़ाम है इन आवर लैब वर्क और स्पेशली जब हम ये देखना चाहेंगे कि कितनी कंसंट्रेशन ऑफ कंटेमिनेंट होगी तो उसके लिए कितनी डोजेज जो है वो रिक्वायर्ड है ऑफ द कोएगुलेंट और फ्लाकुलेंट्स और एनी केमिकल विच इज़ बीइंग एडेड इनटू द रिएक्टर। तो उसके लिए वी शुड बी स्पेसिफिक। सो उसके लिए लेट्स हैव अ बेसिक इन्फॉर्मेशन कि हमारे केमिकल रिएक्शंस कैसे टेक प्लेस करते हैं और वो कैसे फिर आगे उनका जो इक्विलिब्रियम है वो डेवलप होता है। सो what is stoichio? It is for elements, and metry means a measurement. So stoichiometry is about measuring the amount of elements and compounds involved in a reaction. Very simple. Now taking an example कि हमारा ये जो रिएक्शन टेक प्लेस कर रहा है जिसमें अमोनिया रिएक्ट कर रहा है विद ऑक्सीजन एंड इट इज़ yielding नाइट्रिक ऑक्साइड एज वेल एज वाटर. So there are several numbers involved. So इनकी जो significance है वो क्या है इन numbers की? Let's talk about it. So अमोनिया है, इसमें क्या चीज़ है? इसमें नाइट्रोजन है वन एलिमेंट एंड थ्री एटम्स जो हैं वो हाइड्रोजन के हैं. सिमिलरली ऑक्सीजन के टू एटम्स हैं. H2O के अंदर टू हाइड्रोजन एटम्स एंड देन वन ऑक्सीजन एटम. नाइट्रिक ऑक्साइड के अंदर बोथ नाइट्रोजन एंड ऑक्सीजन और वन एटम ईच. एंड देन अगर हम इनके मोलर मैसेज की बात करें तो सिंपली टॉकिंग अबाउट अमोनिया, व्हाट इज़ अमोनिया कंटेनिंग? Ammonia is containing 17 grams per mole. What is 17? It is giving us the number which is a combination of 14 from nitrogen, 3 from hydrogen, and thus the sum up is 17 grams per mole. This is the molar mass जो कि अभी हम कुछ देर में इसको मज़ीद एलेबोरेट करेंगे. Similarly, oxygen is giving us 32 grams per mole, H2O is giving us 18 grams per mole, nitric oxide is 30 grams per mole. Because nitrogen, oxygen, hydrogen, all these are having their atomic numbers which we can get from periodic tables, and by simply summing up we can get it. To find the molar mass of a chemical formula, add the atomic masses of the elements forming the compound. Use the periodic table to determine the atomic mass of individual elements. So this is again we are going to find out what is this equation stands for. उसमें देखें कि अमोनिया के साथ हमने 4 जो लिखा हुआ, व्हाट एक्चुअली इट मीन्स, इट इज़ अ कोफिशिएंट जो कि हम इक्वेशन को जब बैलेंस करते हैं दैट टाइम वी आर गोइंग टू यूज़ दिस कोफिशिएंट सो दैट वी कैन अंडरस्टैंड exactly how much ammonia is being used. Similarly, others have their coefficients. Now, this is the summary of the whole molar ratios. और ये मोलर रेशो क्या है? मोल रेशो क्या है? इट इज़ गिविंग अस द अमाउंट ऑफ मोल ऑफ ईच कंपाउंड में कौन सी चीज़ है? अमोनिया। अगर हम सिर्फ अमोनिया की बात करेंगे तो इट इज़ गोइंग टू हैव 4 मोल्स, 5 मोल्स ऑफ ऑक्सीजन मॉलिक्यूल एंड 6 मोल्स ऑफ H2O, 4 मोल्स ऑफ नाइट्रिक ऑक्साइड। इस तरह से हम इसको बैलेंस करेंगे एंड देन इट इज़ गिविंग अस मोलर रेशो. Now here stoichiometry is going to give us this amount, which I think we have already explained. So how many moles of H2O are produced if 2 moles of O2 are used? अब अगर हम O2 के 2 मोल्स यूज़ करें इंस्टेड ऑफ 5, what H2O number is going to be achieved? उसके लिए अगेन वी शुड नीड दी अ बैलेंस्ड इक्वेशन. उस बैलेंस्ड इक्वेशन के अंदर आप देखें कि कितने मोल्स ईच कंपाउंड जो है वो यूज़ कर रहा है. उसके बाद उसकी रेशो लें और उसको फिर हम यूनिट मेथड के साथ ऑपरेट करके we will be finding out the amount of water which will be yielded as a result of using only 2 moles of oxygen molecule. So this is the summary here. You can see it's quite understandable. Notice the correctly balanced equation is essential to get the right answer. Now in this case अगर आप देखें how many moles of nitric oxide are produced in the reaction if 15 moles of H2O are also produced. So उसके लिए हमने देखना ये है कि कौन से हमारे पास वेरिएबल्स अप्लाई हो रहे हैं. So let's use those variables. नाइट्रिक ऑक्साइड क्योंकि हम डिटर्मिन करने जा रहे हैं उसको हम कंपेयर किया हमने विद द वाटर H2O. तो व्हाट इज देयर प्रोपोर्शन? जस्ट चेक इट हियर. 4 moles of NO एंड 6 moles of H2O. ये हमें एक रेशो प्रोवाइड कर रहा है. अब ये है वो एक बैलेंस्ड और नॉन अमाउंट जो कि हम अडॉप्ट कर चुके हैं, विच वी नो द रिएक्शन इज़ गोइंग टू वर्क इन दिस वे. एंड नाउ वी आर गोइंग टू इंटरपोलेट कि अगर हमारा H2O जो है वो 15 मोल्स तक हो इंस्टेड ऑफ 6, then how much nitric oxide will be yielded in this case. सो इस तरह से हमने यूनिट फार्मूला के थ्रू इसको भी कन्वर्ट किया इनटू नाइट्रिक ऑक्साइड मोल्स फॉर 15 moles of H2O. Similarly, how many grams of H2O are produced if 2.2 moles of ammonia are combined with excess oxygen? Now here is something added up. वो कौन सी चीज़ ऐड हो रही है? वो है ग्राम. सो ग्राम्स का और मोल्स का आपस में क्या रिलेशन है उसको इट नीड टू बी अंडरस्टूड. सो उसको आप इधर ऑब्ज़र्व कीजिए कि फ़र्स्ट ऑफ ऑल वो चीज़ जो कि हमें नोन है दैट इज़ 6 mole H2O एंड 4 moles अमोनिया. इनको हमने इनकी रेशो फाइंड की एंड देन हमारा जो टारगेट था H2O का ग्राम्स की फॉर्म में, तो हमने एक जो जर्नल हमारे पास कन्वर्जन फैक्टर है कि 1 मोल H2O के अंदर कितने ग्राम H2O अवेलेबल है. लाइक 1 mole H2O हैज़ 18.02 grams H2O. सो इसको हमने ऑपरेट करना है, इसको हमने कंज्यूम करना है. सो दिस इज़ द गिवन वैल्यू, दिस इज़ द जर्नल कन्वर्जन फैक्टर. और उसको हमने किसके साथ रिलेट किया? मोल्स की जो प्रोपोर्शन हमारे पास एग्जिस्ट करती है फ्रॉम द मोलर रेशो. then we multiplied it by the factor which we are going to determine. वो क्या है? that is 2.2 moles of ammonia. now this 2.2 moles of ammonia are going to yield 59 grams of H2O. so this is the simple form जो कि आप इधर देख सकते हैं. and then we will move forward. how many grams of O2 are required to produce 0.3 moles of H2O? so इसी तरह से जो कि पिछला पैटर्न था उसको अगर आप फॉलो करें, वी विल बी एबल टू एनालाइज how much grams of oxygen will be produced if we are going to yield this much water. So इस तरह से we can convert moles to grams, and then we can determine how many grams will be yielded as a result of this molar ratio. अब इसमें अगेन वही कॉन्सेप्ट है, इसमें भी वही चीज़ आप यूज़ कर रहे हैं. इट इज़ जस्ट फॉर योर रिवीजन. आप प्लीज़ इनको खुद से सॉल्व आउट कीजिए ताकि यू कैन गेट अ बेटर अंडरस्टैंडिंग of this concept. Moving along the stoichiometry path, इसमें देखिए आपके हम किसको किसके साथ रिलेट करते हैं. सो मोलर मास ऑफ x, उसको हम रिलेट करते हैं मोलर मास ऑफ y, एक और कंपाउंड के साथ. एंड देन मोलर मास के अंदर हम क्या कर रहे हैं कि ग्राम्स को मोल्स के साथ, मोल्स को एंड और दूसरे कंपाउंड के मोल्स को ग्राम्स के साथ रिलेट करते हैं. एंड देन वी गेट mole ratio from the balanced equation, and then we solve it out. ये जो अभी हमने पिछली स्लाइड्स में जो हमने एक्सरसाइज की है, ये उसकी समरी है, उसकी एक रिप्रेजेंटेशन है, हाउ वी आर गोइंग टू अडॉप्ट इट. सो मूविंग फॉरवर्ड, ये आप गो थ्रू कीजिएगा. एंड दीज आर द एग्जाम्पल्स फॉर यू. अगेन इसको भी सॉल्व आउट कीजिए so that you can have a better concept about the conversion from moles to grams. The mole and the stoichiometry, again इसमें थोड़ी सी जो है वो addition है, like we will be adding up some new content. Quantitative study of substances and their relationship to each other in chemical reaction, it is going to represent the stoichiometry. Also, this is called math of chemistry because we are quantifying the things, we are quantifying the atoms, molecules, we are quantifying the number of moles, we are finding out the molar masses, and then from these things we will be relating how we are having chemical formulas, empirical formulas की क्या significance है. So what is a mole? Just for your revision, I think you already have a very good concept. So it is just a number which is going to give us a quantity. It is not, it is going to remain same whether, no matter what our material is, what our item is, it is going to overall find out that all the we are only going to quantify, and it is like in a dozen we have 12 things. No matter whether there are 12 eggs, or there are 12 bananas, or there are 12 bicycles, or there are 12 cars, no matter what it is, we are going to have a generalized term dozen, which is going to give us a quantity of 12. Similarly, in case of this mole, we are going to get a quantity, and that quantity is about 600 to billion trillion things, and this is represented here, and 10 to it is 6.02 into 10 power 23, and this is called the Avogadro's number, and you can find it, its abbreviation is mole. So it is equal to three things. One mole is equal to gram formula mass, molar mass. We talked about it earlier. One mole is equal to 6.02 into 10 power 23 particles, and then one mole is equal to 22.4 liters of gas at standard temperature and pressure, STP. So this is all about these conversions of these three particles. And then 1 mole of aluminium can be 6.02 to 10 power 23 atoms. 1 mole of H2O again having the same number of molecules. Similarly we will be having anything which is going to be expressed in terms of mole, that actually means 6.02 into 10 power 23. Then represent it in whatever category it falls, whether atoms, whether molecules, whether particles, anything could be included in it. The number of particles is always the same, but the mass of each mole may be very different. We are talking about mole, we are talking about the number, we are not talking about the mass. So molar mass is equal to mass of one mole of particle in grams. So again, it will be depending what we are going to use and how we are going to represent it. So 1 mole of C atom is equal to 12 grams, and 1 mole of magnesium 24, 1 mole of copper is equal to 63.5 grams. So these are talking about atoms. It is not about molecules or anything else. Similarly, if we use here like C2 or H2O, in that case we will be finding out the total molecular weight of that in 1 mole, which will be giving us the grams in 1 mole. So please solve it out. I think it's not a big issue. Gram molecular mass or molecular mass, and 1 mole of CaCl2 is going to give us all the summation of all the atoms and molecules present in calcium chloride. We talked about it earlier. You can find it by yourself. This is the calculation with molar mass, converting moles and grams. So 1 mole is of aluminium is equal to 27 grams aluminium, and if there are 3 moles, then we will be multiplying it by 3. It's quite simple. We just talked about it earlier. Then if we have 30 grams of CO2, how many moles do you have? If you have 6 moles, then how many grams do you have? So please go through it, solve by it yourself. These are quite simple examples. So again, like atoms, molecules, particles are also giving us the same number, which are present in 1 mole. A mole of particles, a mole of 1 mole C, 1 mole H2O, 1 mole NaCl, and 1 mole of gas will be giving us 22.4 liters of any gas at standard temperature and pressure. So this is the percentage composition. Again, if it is a percentage of by mass of each element in a formula. So calculating the percentage composition of CO2, CO2 is equal to 1 into 12 plus 2 into O2, and O2 is giving us one oxygen atom giving us 16 grams. So overall total it will be giving us 44 grams per mole in 1 CO2 mole. And then if you going to find out the percentage, uh, multiply it by 100 for each carbon atom gram, and the grams of in 1 carbon atom. And similarly, how many grams in oxygen are used overall, and getting their percentage, multiplying by 100. What is the percentage composition of lactic acid? This is that appears in the blood after vigorous activity. So again, it's not difficult. I think you can do it by yourself. This first of all, step 1 giving us the overall molecular weight, molar mass, And then if we are going to find the percentage, we will be finding how much carbon in grams are there, and dividing by the total molar mass and multiplying by 100, then we can get the percentage composition is described here. This is a quite simple things actually, mainly talking about it. It's just kind of revision. So empirical formula expresses the smallest whole number ratio of the atoms which are present. So ionic formulas are always empirical formulas which give us the simplest proportion in which the atoms are bound together. So molecular formula here states actually number of each kind of atom found in one molecule of the compound. Now molecular weight is going to give us the actual number of each kind of atom, how much it is being consumed. For example, C6H12O6 giving us the formula, and then C11H22 O 11. So this is going to give us again a molecular formula. And if you find out the um, empirical formula for these carbohydrate and glucose formulas, you will be simplifying it. You will be only talking about the ratio in which the compounds are mixed. So divide C11H22O11 by the smallest number, which is 11. You will get the empirical formula, that is CH2 and O. So this is the example here. Um, so this is the formula C5H10O5, multiplying dividing by the smallest number 5, giving us the empirical formula CH2O. And here we have some molecular formulas compared with the empirical formulas. You can find it by yourself. It's quite simple. I think it's these are just calculations. Please go through it by yourself. Here is the percentage is already given in this. Like aspirin is 60% carbon and 4.5% H and 35.5% oxygen. Calculate its empirical formula. So now we know the percentage, and we will be now expressing how they will be reacting. So if you have calculate moles of each element in 100 gram. So in this way we will be having about percentages, and then let's talk about the percentages in terms of grams, and then these grams will be divided by the actual atomic weight of that compound, that atom. So this is going to give us the overall proportion. So if you further simplify this equation, 2.252 and 1, and then you will be getting the formula like this. So please, these are just examples. You can go through these examples by yourself. This is the molarity, is the term used to express concentration. The units of molarity are moles per liter. It is abbreviated as capital M. In most of the cases, when we deal with environmental chemistry, we are talking about molarity because different compounds, different chemicals are standardized at a particular molarity so that we can specify its strength. For example, H2O, H2SO4, HCl, they have certain strength, how much the number of moles are present in per liter of the that particular acid or base. So we must know their molarities. So actually molarity is giving us the concentration. Again, concentration is a very commonly used and term in our environmental chemistry and in our environmental design assignments. You will be dealing with this concentration off and on. So in this case, if you are going to express something, it will be expressed in terms of moles rather than grams. For example, if we simply talk about concentration, what it is giving us, it's actually giving us the mass in unit volume in a particular area, sorry, in a particular volume, how much mass of a particular contaminant or compound is present. This is called concentration. But if you relate this concentration with the molarity, in this relationship, you will find that now the concentration is expressed in terms of moles, not in grams. Again, we are concerned about the molar values. So how much how much number is going to be used. So it is actually again going to give us the strength of the acids and bases. So moles per liter, moles per 1000 ml, this is something about the expressions. Now this is some more examples. 50 ml of H2SO4 and baking soda is to be used to neutralize the acid. How many grams of NaHCO3 must be used? So quite understandable that you can simply first of all balance the equation, then find the uh, um, amount of H2SO4 being used and then its molarity. So for example, 50 ml of 6m H2SO4, this M, capital M, is showing the molarity. So now we have the moles in it, moles per liter, and this is 50 ml is the volume. So from here we can reverse back to find the number of moles, and then we are actually going to find the baking soda in terms of grams. What will we be doing here? We will be simplifying the equation. H2SO4 in terms of 50 milliliters, 6 moles per 1000 milliliters, this is the molarity. Then this is the baking soda, and we are using it 2 moles, and while comparing it with our balanced equation, how many moles of H2SO4 are used? It is 1. And then now the next time we will be using the conversion factor. Now this conversion factor is giving us conversion from 1 mole to the number of grams in that mole for the baking soda, and that is giving us 84 grams. Now simplifying the equation, we can get the total number of grams which will be required, which will be required to find to get the end product to neutralize the acid. Similarly, this is another equation, and this is on the same pattern as the previous one. Please solve these numericals examples. These are very simplified and interesting as well. So calculations with equal chemical formulas and equations. Now this is again kind of repetition, just for your own revision, and these were some good slides I found, and I want to share with you. Please go through them, and it is again the same thing which we have already done. So the reactants and appears on the left side, and products appear on the right side. So this is the anatomy of the, so here you are going to understand the coefficients, and then reaction types. So two or more substances react to form one product, so combination reactions, decomposition reactions, and then combustion reaction. What is the formula weight? The AMU unit, atomic mass unit. So it was the origin of it is from the isotope of carbon at giving us 12 grams. That is the basic isotope used to represent this AMU. So some of the atomic weights for the atoms in chemical formula you can see here: molecular weight, percent composition, moles. We have talked about it already, just this is the revision. Please go through. Finding empirical formulas, this is how we can find the empirical formula. Calculating empirical formulas. So here the stoichiometry and kind of repetition. Limiting reactants, the amount which is in the smallest quantity which is going to govern the reaction. So this is a very good example of sugar usage in making the cookies. You can go through it. The limiting reactant is the reactant present in the smallest stoichiometric amount. Theoretical yield, which we can obtain from the equations. Percentage yield is actual yield over theoretical yield multiplied by 100. So that's all about this basics of stoichiometry and concept of mole and the chemical reactions and their equilibriums. Please go through this stuff by yourself. It's quite a vast topic. So more you learn, more you go through, more the learning you can obtain. And that's all for today's lecture. Thank you very much.